Hi everybody, my name is Professor Rad, and today we're going to simplify fractions by using a technique of repeated division. In the last video, we used the greatest common factor to simplify fractions. Today we're going to use sort of a similar kind of technique where we're going to be using division, but it's going to be a little bit different because we're not necessarily going to look for the greatest common factor right away. So here's what this looks like. So I'm going to bring a calculator here to help me out. And what I'm going to do, this works best if you know your multiplication tables or your divisibility tricks. So if you're comfortable with those, you might like this technique a little bit. So what I'm going to do is I'm going to look at 30 and 105, and I'm going to say, is there any number that I can think of that isn't 1 that goes into both of these numbers? So for me, for example, I notice that the top ends in 0 and the bottom ends in 5. And I know that 5 is going to be a factor of any number that ends in either 0 or 5. So I know 5 is going to work here. So what I'm going to do is I'm going to divide the top by 5 and the bottom by 5. So 30 divided by 5 gives me 6. And then 105 divided by 5 gives me 21. Now, to see if this fraction is reduced, I'm going to kind of exhale, clear my brain, and now treat this like a new problem. I'm going to look at this new numerator and denominator, 6 and 21. Do these two have anything in common? So in this case, I know both of these are multiples of 3. 3 goes into 6, and 3 goes into 21. 3 goes into 6 twice, and it goes into 21 7 times. So I divided the top and bottom by 3, and now we get 2/7. At this point, I know that 2 and 7 are both prime numbers, so the only thing that goes into either one is 1 or itself. So because 2 and 7 don't have any factors in common other than 1, that means we are now in simplest form. To check my answer, I'm going to type this fraction into the calculator, 30 over 105. And when I hit enter, it gives me the fraction in simplest form. Okay, so now let's look at part B, and we're going to do the same technique. But to me, what's different about part B is that these are much larger numbers, and I don't know as much about them as I did about the other numbers. So the best I can notice here is that these are both evens. So I know 2 is going to go into both of these numbers. So I get 110, and then 21. Okay, so now this is where I hit a disadvantage to this technique. And a disadvantage to this technique is that it's not always clear when you're done. So in the previous example, part A, right, I recognized both 6 and 21 had a common factor of 3, so I knew I wasn't done. And then 2 and 7 are pretty small, so I could easily kind of compare them or think about them and know I was done. With 110 over 21, I don't know. I don't know if I'm done or not. I'm more familiar with 21. I know that 21 is going to break into 1 times 21 or 3 times 7. And that's it. I know that those are the only ways I can break apart 21. So what I'm going to do, I'm going to ignore 1 because 1 goes into everything. And I'm going to see if any of the remaining factors go into 110. So I'm going to try 110 divided by 3. And nice terrible decimal. So I know that won't work. Let's try 110 divided by 21. Nope, that one won't work. So our last hope, if we're going to simplify, is to use 7. And 7 didn't work. So the only things that would work with 21, the only things that go into 21, don't go into 110 other than 1. Which means that this is in simplest form. We can't break that one down anymore. To confirm that, let's check on our calculator. So I'm going to do 220 over 42, and it gives me 110 over 21. Let's work through another one together as well. So here I have 16 over 144. And again, I notice both of these are even numbers, so let's divide those by 2. That gives me 8. And 72. All right, nice. Now I know that 8 and 72 are also still both even. So I know 8 divided by 2 is going to be 4. Let's try 72. 36. Now I also noticed that both 4 and 36 are even, so I could divide both by 2 again if I wanted to. But I'm actually going to choose 4 because I know that 4 goes into 4 and 4 also goes into 36. So I'm going to divide the top and bottom by 4 and get 1/9 as my final answer. But just to show you, you could use 2. I'll show you what would have happened if we did 4 over 36 and we divided the top by 2 and the bottom by 2. We would get 2 over 18. And I would have said, hey, both of these are even, so we can divide by 2 again. And that would give me 1 over 9, which is the same answer we got by dividing by 4. So if you look at these numbers and you identify a factor that's going to go into both top and bottom, you can go ahead and divide by that. So for example, looking at 8 over 72, I know 8 goes into 72. That's part of the 8 times tables. So instead of dividing by 2, I could have just divided by 8 right here and made my work shorter to get 1/9, which again is what we got. So when you use repeated division, unlike with the greatest common factor, you get lots of correct pathways. With the greatest common factor, you're only ever dividing by one number from the top and bottom. When you use repeated division, it's whatever you see. If you see 8 here going into both top and bottom, use it. If you see 2 going into both top and bottom, you can use that. You have lots of different pathways. Just like when we make a factor tree, there are lots of different factor trees that could be made. Okay, so I started bleeding into this next area a little bit, so I'm going to draw a line to keep them separate. And let's go ahead with 114 over 57. So, I think 3 is going to work, and I say that because if I add 4 plus 1 plus 1, I get 6, and 3 goes into 6. And for 57, if I add 7 and 5, I get 12, and 3 goes into 12. But let's say I didn't notice that. Let's say I looked at 114 and 57, and I was like, I don't know where to start with this. Start with 2. So 114 divided by 2, that worked, great. 57 divided by 2, that one didn't work. So if you get a decimal, that means it doesn't work, and you want to check the next number. So since 2 didn't work, let's try 3. 114 divided by 3 gave me a whole number, so that worked. 57 divided by 3 also gave me a whole number, so that worked. So I can divide the top by 3 and the bottom by 3. So that will give me a 38 up top and a 19 below. And now I'm going to keep going with that method. If I'm not sure when to stop, I'm going to keep checking. So let's see. 3 didn't work. Or sorry, 3 worked. Let me check 3 again. 3 didn't work. Okay, so let's try 4. Okay, and the nice thing is if it doesn't work in the top number, I'm not even going to bother trying it in the bottom because it has to work in both. Okay, so I have to get a whole number when I divide. So let's try 5. Nope. 6 doesn't work. How about 7? No. 8? No. Okay, and at this point, I'm starting to wonder, am I going to be doing this forever? So how do I know when to stop? Well, in part B, I knew to stop because 21 was familiar to me, and I knew just the factors of 21, so I could use that to stop. But let's say neither 38 nor 19 are familiar to me. Like, I don't recognize much about either of these numbers. I'm going to keep going until I hit the smaller number. So in this case, I've got to keep going till I hit 19. That'll be my last hope. So right now I'm at 8, so I'm going to just keep going. Let's try 9. Nope. 10 doesn't work. Nope, not 11. 12. 13. 14, 15, 16, lots of decimals here. I'm starting to lose hope on this one. Oh, hey. 19 went into 38 twice, and 19 is the bottom number. That means 19 goes into 19 once. So our last possible hope, which was 19, turned out to be one that worked. So that's why we always have to go to whichever of these numbers is smaller. So 38 divided by 19 is 2, and 19 divided by 19 is 1. Now, anything over 1 is itself, so we end up getting just 2. So a lot of different techniques that you can try as you do your repeated division. So actually, I kind of lied a little bit. I knew a little bit about 19 when I was working through this. What I knew about 19 is that 19's prime. So if you recognize one of the numbers as a prime number, then all you have to do is try that one. So once I got to 38 over 19, I didn't have to check 2, 3, 4, 5, and so on. I only had to check 19 because I know 19 is prime. But sometimes you might think a number is prime, and especially if it's a large or uncommon number. So like, for example, when I initially looked at 114 over 57, my first thought was, is 57 prime? So sometimes you might look at a number and think it's prime, but maybe it's not. So unless you know for sure that it's prime, you want to check all the factors leading up to it. So yeah, so sometimes your work looks pretty minimal. So this work looks pretty minimal, although we did an awful lot in the calculator. Over here, similar kind of experience. On this one, if you know factors of either the top or the bottom, you can use that to guide you as you check your factors. And sometimes it just looks a mess. Sometimes you just keep going until you can't anymore. So I've got a few fractions for you to try and simplify using this technique. So see if you can simplify each of these fractions by using the method of repeated division. Okay, and then in the next video, we'll talk about one more technique, which if you're heading into algebra, this next technique is probably the best one to work through because it works the best for algebra. So I am looking forward to seeing you then. In the meantime, have a great day.